In today's video, I would like to introduce a very nice problem regarding arithmetical number. Here is the following equation. So the left hand side of this equation involving the polynomial of degree 4 and the right hand side of this equation involving the power of 10. Okay, so I see all the terms are in good conditions to complete the square here, except the last term. The last term I'm going to split this number into two terms in order to complete the square of this equation. Okay, so let's go straight to the solution to see this one was given us. So I'm going to write this one as a perfect square. So I get here 3x squared plus number 1 quaternary square equals this term, which is 17, is multiplied by 10 to the y minus number 1. So what I have done here, I just put this one on the form of the perfect square, which is good to go here, because we have 9x squared plus 6x squared. We have the last term plus number 1. We'll be left with another one here. That the one that I left here, I move it over to the right, becomes minus 1. Okay, I'm going through three cases. The case number 1, what about if y strictly inferior than 0? Okay, so let's work on this one first. So we know this one is super equal to 0 because we have a perfect square here, which means this one positive, this one is positive as well. By moving over minus 1 to the right, I will be ended with this following term. 17 is multiplied by 10 to the y is super equal to 1. Since we are working over negative integers here, I'm going to take the inverse of this. So I get here 17 is super equal to 10 to the minus y. Let's go through the substitution. Let's put this one on the form of 10 to the a, where is a equals minus y, which is super equal to 1. Okay, why this one is super equal to 1? Because if I'm going to multiply this one by minus sign here, I get minus y is strictly superior than 0. In the other word, minus y is super equal to 1. Okay, which equals to a. But a here in this case is super equal to 1. But if a equals 1, this inequality is true because 17 is bigger than 10. Okay, but this one, it's impossible if a is super equal to 2. Okay, let's switch. If a is super equal to 2, becomes this one 100 here as a minimum value. I get 17 is super equal to 100, which is impossible. Okay, so we need to check the case when we have a equals 1. If a minus y equals 1, okay, which means y equals minus 1. Okay, let's plug this one into the original one to see we may have a solution or not. We get 3x squared plus number 1 quaternary square equals 17 is multiplied by 10 to the minus 1, which equals 17 over 10 minus 1. But this one is not integer. Okay, also it's impossible. Now let's go to the case number 2. If y equals 0. Okay, if y equals 0, I'm simply going to replace this 0 into the original one, taking this value of y, which is 0, and plug it into the original one here to see what's the expression. So this one is giving us 3x squared plus number 1 quaternary square equals 17 minus 1, which equals 16. Okay, by taking the square root on both sides, I get 3x squared plus number 1 equals plus or minus 4. But we are not going to take minus 4 because this one is positive. Okay, let's cancel out the minus sign from here. But moving over number 1 to the right, I will be end with x squared. I get 4 minus 1, which is 3 over 3, which is 1. Okay, so this one is giving us x equals plus or minus 1. Let's take the first solution for this one. The first obvious solution, x equals 1, corresponding to y equals 0. So the other solution, which is negative, x equals minus 1, corresponds with the same value of y, which is 0. Okay, so I have extracted two solutions from here. Now let's move on to the next case when we have y equals 1. Okay, if y equals 1, so I'm simply going to replace this value of y into this one. I get 3x squared plus number 1 quantity squared equals 17 is multiplied by 10 minus 1. This one is given as 170 minus 1, which is 169. We know 169, which is the same as 13 squared. So I get, taking the square root on both sides, I get 3x squared plus number 1 equals 13. We are not taking the minus sign because this one is a positive. So let's move over number 1 to the right. I get x squared, 13 minus 1, which is 12, 12 over 3, which is 4. Okay, taking the square root on both sides, I get x equals plus or minus 2. So I get the second obvious solution. I get x equals 2 corresponding with y equals 1. Also, I get x equals minus 2 corresponding with y equals 1. Okay, I have extracted the 4 solutions. Let's move on to the general case when you have y is super or equal to 2. Okay, so I'm going to work a little bit over here. So I get 3x squared plus number 1 quantity squared equals 17. I'm going to split this one into 2 terms. I get 2 to the y is multiplied by 5 to the y minus number 1. Okay, now if you have y is super equal to 2, this term will be divisible by number 4. Okay, let's reduce this one to mod 4. Okay, and also let's put as a substitution this one as a z. So we get the following. I get z squared equals this term 2 to the y is multiplied by 17 is multiplied by 5 to the y minus number 1. Okay, let's reduce this one to mod 4. If I'm going to do that, I will be left with this one will be 0, it will be congruent to minus 1 mod 4. As I said before, 2 to the y will be divisible by number 4, so I will be left, so the whole product it will be 0. Okay, the congruent. I get minus 1 to the mod 4. Now let's compare the remainder. So adding number 4 here, I get this one is congruent to 3 mod 4. But remember, we get a perfect square here is always 0 or 1 mod 4, because if you go through the chart here, so I get the following values. I get k, for example, I get k squared 0, the value 0, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. This one will be reduced to the mod 4. So I get the following values. The remainder 0 here, the remainder 1, the remainder I get 2 squared, which is 4, it will be divisible by number 4, remainder 0. I get 9 here, 9 remainder 1, I get 16, 0, 1, 0, 1, and so on and so forth. So this one is belongs to 0, 1 as a set. Okay, so but the problem, we get a different remainder. We have an absence of number 3 here. So we get here 3x squared plus number 1, which is quantity squared, which equals z squared, is different than 3 mod 4, based on this information which you have in this set, which means we have no solutions above this point, y is super equal to 2. So the only solution that we found, this one. So I have ended this video. Don't forget to hit the subscribe button and support the channel, and thank you for watching. I will see you next video. Bye.